In October 2017, something extraordinary crossed the invisible border of our solar system. A silent traveler, fast, strange, and utterly unfamiliar, appeared in our skies. Telescopes around the world caught only a glimpse, a faint streak of light cutting through the blackness at a speed no ordinary comet or asteroid could reach. At first, scientists thought it might be a comet, one of those icy drifters that carry the frozen breath of distant worlds. But comets have tails, bright, glittering streams of vapor and dust. This one had none. It didn't glow, didn't shed material, and left no trace behind. It simply moved, swiftly, precisely, and with a purpose that no one could explain. It became the first known interstellar object ever observed passing through our solar system. Astronomers named it Oumuamua, a Hawaiian term meaning messenger from afar. And for many, it truly felt like a message, a whisper from deep space, a sign that the universe still holds mysteries waiting to be heard. From the beginning, Oumuamua defied every rule. Its path through the solar system was hyperbolic, meaning it didn't come from here and would never return. It entered at nearly 315,000 kilometers per hour, swung around the sun, and vanished into the dark, like a visitor merely pausing to be seen. But what left scientists truly speechless was its motion. It didn't move like a rock. It didn't behave like a comet. As it drifted away from the sun, it began to accelerate, ever so slightly but undeniably, as though something unseen was pushing it. Gravity alone couldn't explain it. Theories began to multiply. Some said it might be made of pure hydrogen ice, slowly evaporating in sunlight. Others imagined it as a fragment of frozen nitrogen, a shard torn from the surface of an ancient exoplanet. And then came a far bolder possibility, that it wasn't natural at all. Could Oumuamua be a probe, a relic from another civilization, sailing between the stars on a journey older than humankind itself? The idea set imaginations ablaze. For the first time, astronomy wasn't just about looking outward, it was about asking whether something out there might be looking back. No telescope on Earth could see it clearly. By the time we noticed it, Oumuamua was already speeding away, too distant, too small, too fast. But then came hope. The James Webb Space Telescope, launched in 2021, humanity's most advanced eye on the cosmos. A golden mirror floating a million miles from Earth, designed to see the faintest light and peer into cosmic dust and time itself. When Webb turned its gaze toward the receding visitor, now drifting far beyond Neptune, it caught something astonishing. Oumuamua appeared long and narrow, a twisted shard reflecting faint red light. Its surface was rough, scarred, and ancient, carved by countless impacts and cosmic rays over eons. It looked like a fossil of the galaxy itself. Yet Webb's instruments revealed something even more remarkable. The light bouncing off its surface carried the unmistakable fingerprints of organic molecules, complex carbon-based compounds rarely found together in our solar system. It suggested that Oumuamua had been born in a region of the galaxy unlike our own, perhaps richer, wilder, more chemically diverse. Its composition hinted at the possibility that life's raw ingredients could exist in forms we've never seen. Still, the greatest riddle remained, its strange acceleration. There were no jets of gas, no debris, no evidence of outgassing or melting. It was as if Oumuamua were responding to light itself, propelled gently by the radiation of nearby stars. A few scientists whispered the term, light sail. Could it be a natural crystal structure so thin that sunlight pushed it, or something designed, a relic of technology far beyond ours? Webb's high-resolution data revealed shimmering metallic flecks and reflective crystals embedded in its surface, perhaps the cause of its unusual brightness. Each layer of that strange material carried clues about the suns it had passed, the dust storms it endured, and the long, silent journey it had taken through interstellar space. In October 2017, something extraordinary entered our solar system. A faint streak of light, a traveler from another realm, gliding silently through the void. Its name would become a symbol of mystery. Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. It was unlike anything humanity had ever seen. Not a comet. Not an asteroid. Not a fragment of anything familiar. It moved too fast, spun too oddly, and carried no tail of dust or ice. Instead, it slipped through the solar system like a whisper, swift, precise, and inexplicably alive with motion. Astronomers across the world scrambled to study it. Its path was hyperbolic, a mathematical signature that revealed a breathtaking truth. This object did not belong here. It had come from the stars, a visitor from another system, perhaps even another galaxy, passing through ours for the first and only time. As it raced past the sun, something strange happened. Oumuamua began to accelerate, ever so slightly, as though being pushed by an invisible hand. No gravity could explain it. No outgassing, no tail, no exhaust. It was as if it was responding to light itself, like a sail catching the wind of starlight. And so, a new question emerged. Was Oumuamua a natural fragment, or something designed? For centuries, humanity has looked at the heavens and wondered if we are alone. But this was the first time that wonder looked back. Could this be a probe, an ancient relic sent across the cosmos by another civilization? Or was it something even more profound, a messenger of life itself? As years passed and the object slipped beyond the reach of our telescopes, the mystery only deepened. Then came the James Webb Space Telescope, humanity's most powerful eye on the universe. Launched in 2021, it was built to see the invisible, the cold glow of distant galaxies, the heat of alien worlds, and perhaps, the truth behind Oumuamua. When Webb finally turned its golden mirrors toward the region where Oumuamua had traveled, it caught a faint reflection, the last echoes of sunlight bouncing off a shape long gone. The data it gathered painted a haunting portrait, a long, narrow shard, irregular and metallic, scarred by ages of cosmic radiation. Its surface glimmered with complex organic molecules, carbon chains, metallic minerals, and crystalline compounds unlike anything found in our solar system. It was, in a sense, a time capsule, carrying within it the chemical history of the cosmos. Each particle on its surface was a record of distant stars, of collisions, of centuries adrift in the darkness between galaxies. It was not just an object, it was a memory. Somewhere, long ago, a young star system might have been torn apart by gravity's fury, a dying sun collapsing, or a massive planet shattered by tidal forces. From that chaos, Oumuamua could have been born, flung into eternal exile, a silent witness to a catastrophe billions of years old. A survivor wandering forever between the stars. But another theory took hold, one even more profound. Perhaps, Oumuamua was not merely a survivor, but a seed. A carrier of life's ingredients, journeying across the galaxy like a cosmic messenger. Scientists call this idea interstellar panspermia, the hypothesis that the building blocks of life can travel between worlds aboard interstellar debris. In that view, objects like Oumuamua are not just rocks, they are vessels. Drifting for eons, they carry amino acids, carbon molecules, and organic dust, the very ingredients that, under the right conditions, can spark life. Imagine it. Tiny molecular seeds, asleep for billions of years, carried through the darkness, until they fall upon a warm, watery world, and awaken. Could it be that long before life began on Earth, messengers like Oumuamua had already passed this way? Could our own origins trace back to travelers from distant suns? If that's true, then life itself might be a cosmic continuum, spreading like pollen on the solar wind, connecting worlds across time and space. life would not be rare. It would be inevitable, wherever the universe allows it to bloom. The arrival of Oumuamua transformed more than astronomy. It reshaped our sense of place in the cosmos. It reminded us that the solar system is not an island, but part of a vast ocean, alive with motion, memory, and possibility. Now, inspired by its mystery, scientists are preparing to chase the next interstellar visitor. Projects like Breakthrough Starshot dream of launching miniature spacecraft propelled by beams of light, traveling at a fraction of light speed to explore nearby stars. Others envision intercept missions, probes waiting at the edge of our solar system, ready to pursue the next object that dares to cross into our cosmic backyard. For the first time, humanity is not just observing